Hey, Joaquin. I'll be back in a few minutes, okay? And we'll get started.
Okay.
All right. Hey, Joaquin.
Hello.
How are you?
Good. How
All
are
right.
you?
I'm good. Do you have any specific questions? Or do you want me to just kind of walk through Robot
Um,
C?
you go walk through robots.
Okay, cool. So I'm going to kind of walk through what I did for this lesson. And then I'm also recording. Hang on, someone else is coming into the room. I'm also recording the session so that anybody else that wasn't able to make it, if they have any questions, they can come back and watch. All right. So we're shifting away from our block-based coding for the rest of this year over to some text-based coding. And so the biggest challenge is going to be in getting the syntax right. And the syntax means making sure that we type everything correctly. When we did the block-based coding, we knew exactly what we wanted to happen on different things, and we just could drag the blocks over, and there was no way to really mess up the wording of the code. Like, we might do the code in the wrong order, and that would not be particularly good, but we wouldn't have syntax errors. So one of the things we have to be really careful of as we start writing out our code in a text-based code is we have to make sure that we type everything correctly. And that means that if there's supposed to be a capital letter, we have to use a capital letter. If there's supposed to be a lowercase letter, we have to use a lowercase letter. And every little detail is going to matter when we start doing that. So one of the first things you learned in the videos from today and from yesterday was that the body of our text, the body of our code, is always going to sit inside of task main. Okay, so task main is where the robot goes to look when it wants to understand what it's supposed to be doing. So all of the code that we write today is going to sit in this area between this curly brace and this curly brace right here. Okay, any code we write outside of that, the robot's not going to do that part of the code. The second thing that I want to call your attention to, and it wasn't actually specifically said in the videos, but when we were doing the text-based coding, there were a lot of times where I asked you to leave a comment in the code. Okay, and the way that you leave a comment when you're writing code in Robot C is you leave a comment with a // If we do that // then anything that we write after that is going to be a comment. So for example, I know that I want to move the robot forward. And notice that when I write a comment, it turns green, just like it used to do in the block-based code, right? The green, the move robot comment would have been a green block, whereas all the rest of our blocks would have been orange in the past. Okay, so we're gonna move our robot forward. But we don't even know what the challenge is yet. So what I'm gonna recommend that we do is we're gonna check a few settings. And the first setting we're gonna check is we're gonna make sure that we are downloading and compiling to the right place. Right now, we're downloading and compiling to the physical robot, but for the rest of this year, what we need to be compiling and downloading to is what instead?
Virtual.
To the
Virtual
virtual
world.
worlds, right? Because that's where we're gonna be able to run our robots since we don't have them at home. So we wanna make sure we're doing this in the virtual world. We're also gonna go into our motors and sensors setup, and we're gonna pick a configuration for our robot. And we're gonna go ahead and use we're gonna use a SquareBot for this, okay? So I'm gonna use a SquareBot. I think the recommendation might have been, I don't know. I don't remember what robot they recommended. It might have been a SwerveBot. We're gonna use a SquareBot for this robot. So I'm gonna apply that. And what that's gonna do is it's gonna set all of my motors for me. Okay, so because this is a virtual robot, we don't actually know where every motor and sensor is plugged in. And so we're just gonna use this SquareBot configuration for our robot. And the last thing we wanna make sure that we do, if we go up to the top and check in the window, is we wanna make sure that we're downloading into the correct virtual world. And for all of these activities in CS2N, we're gonna always download into the curriculum companion. That's where all the little activities are hiding, okay? So now that I've done that, I'm gonna go ahead and click download to robot. And before it will let me download, I have to save this file somewhere. And the name of the activity we were doing, I think was called SumoBot, if I'm correct. So I'm gonna save it as SumoBot. And when I click download to robot, my robot virtual world screen is gonna pop up like that. And so the first thing that you're gonna do when you log into Robot Virtual Worlds is you're gonna use your CS2N password to log into to CS2N. Because Robot Virtual Worlds will connect with the CS2N platform so that as you finish activities in Robot Virtual Worlds, you get credit for them in CS2N. But the only way that's gonna happen is if you log in using whatever you use to create your CS2N account. If you just log in locally, it's gonna like save progress to your computer, but that progress is not gonna be visual to me. Okay, so you wanna make sure that you're logging in using CS2N. So I'm gonna log in, and I'm gonna tell my program that the robot I wanna use is the SquareBot. So I went and clicked on Robot SquareBot, and I'm gonna go to Movement, and I'm gonna pick the activity we're doing, which in this case, the activity we're doing is called SumoBot. Okay? So right here, before I go any further, it tells me what the goal of this activity is. My robot is gonna start right here where that little letter A is. And the goal of this activity is to push these 3 soda cans outside of the circle. Okay? There's a specification document here that gives you some of the measurements, but what I would rather do is just start the activity. And once I'm in the virtual world, I can figure out some of these distances myself. And so in the first video I posted, I showed how we can find distances in here. If we click on this little show beam, that red beam, it shows me the direction that my robot's heading. And if I add a point along that beam, it will then tell me, let's see, let me turn my beam off for a minute. Show, add. Oh, it's not doing it. That's good. Add point. Okay, it's not doing it right now, but it will generally tell me how far I need to travel. Okay, so we can click this little add button to see how far I need to travel in any particular direction. My soda cans are right here in the middle. Let me throw, okay, that sensor is going out that way. Cool. Okay. I don't know why it's not clicking right now, but it's all right. We can check our different views for our camera. So we're kind of lined up with the soda can. In order to push the soda can out of the circle, what do you think we need to do to our code?
You have to move it forward.
Okay, so we're gonna move our robot forward. So I'm gonna go ahead and just click back on my code. I don't have to close that other window, it'll just jump to the back. And in order to move our robot forward, we're going to set some motors. And the way we set motors is we type the word motor, and then we use a bracket, and in the bracket, we tell it which port of the motor we wanna use. So if we wanna move forward, that means we want both of our motors to move forward. Okay, we want our motors moving forward. And so if I go over to my motors and sensors, we're gonna see that the driving motors, the left and right motor, are sitting in port 2 and in port 3. So I'm gonna say motor, port 2, close my bracket. And I wanna set that motor to a specific power level. In EDR, the max power is 127. That's the maximum power. In IQ, what was the maximum power before?
100.
100, right? So the max power in Cortex in EDR is 127 for these particular motors that we're using. So I'm going to set it to maximum power, which is 127. And at the end of any line that we want something to happen, we put a semicolon. A semicolon ends that command and says, I want you to do this, Mr. Robot. If you don't put the semicolon, it will not do that. Okay? So I'm also going to tab over and I'm going to leave a comment here. Okay, and the comments I'm going to leave, in this case, that was port 2. Port 2 was right motor. That's going to say right motor forward, so that I now know exactly what that line was in charge of doing. If I only turn the right motor on, Joaquin, what's going to happen to my robot?
It's gonna spin.
It's going to spin in a circle. So what other motor do I have to turn on?
Motor 3.
Motor 3, which was my left motor. Okay, so we're going to go motor in port 3, set that to 127. I'm going to put my semicolon on the end so that I end that line of code, and I'm going to say left motor forward. This now should just run my motors forward forever. Okay, I don't need them to run forward forever. One of the other things that we learned in the videos, we learned how to use a timer. Okay, so one of the videos today told us how to use a timer, and so I'm going to use a timer right here. We're going to do a wait. We're going to do a wait 1 msec. And what's really cool in here is as we start typing commands, it starts to guess what we want. And that kind of helps us a little bit to make sure that we're typing a real command and we're not making something up. So we're going to wait 1 millisecond, and we're going to do that for, let's do this for about 4,000 milliseconds. That's 4 seconds, right? And so I'm going to have that. I'm going to end that command, and I'll go over and comment, and I'm going to write wait 4 seconds before continuing code. After those 4 seconds are done, what's going to happen to my code is my code's going to end, because now I'm at the end of task main. Okay, so I don't even need in that moment to do like any kind of like set motor to 0. Like I don't have to stop those motors because the code just ended, so everything's going to turn off. Does that make sense?
Yeah.
Okay, what questions do you have about what's there so far?
Nothing.
Okay. So let's run it. We're going to go ahead and download that to our robot. And the window for Robot Virtual Worlds is going to pop back to the front. What's nice about not closing it each time is I don't have to reset the robot or the movement. It already knows what I want to do. I just have to click Start Activity. Okay. And I'm going to click Play. This play button should run my code. And for 4 seconds, this robot should move forward. And let's watch it. Okay. What happened? Did you see what happened? What was that?
It got stuck.
It got stuck, okay? And the reason it got stuck is because these cans either were too heavy or had too much friction, so my robot does not have enough power to push them out. Okay, and so the first time that I was running this code, I kept running into that problem, and I was thinking, what do I need to do? How can I fix that problem? Do you have any thoughts on how we could fix that problem while still using this robot? I keep replaying it, and I keep getting a very similar result, right? We keep getting stuck on the cans. Any thoughts on how we could solve that problem? It's okay if you don't have any thoughts. Go ahead. Not really. So what's causing friction on these cans is that there's a lot of the can surface touching the ground. If I could get these cans off the ground a little bit, then I might be able to push them. Okay, so what might I be able to do to get these cans off the ground?
I have to lift them.
Yeah, I could lift them or use the arm in some way. Okay, so let's try to do that. We're gonna go back over to our code. I'm gonna reset this so it's ready for us when we have some code. And if you notice, let's go back to the virtual world for a minute. I want you to notice something about the arm. The arm is currently in the up position. So before I get to the cans, I'm going to need to move the arm to the down position, right? So before I even move forward, we're going to have a new line of code here. And we're going to have a line of code that moves the arm down. Move arm down. Okay, so to move the arm down, we're going to have to use a motor we haven't used yet. We're going to have to use an arm motor, and we're going to go check our motors and sensors to figure out where that is. And what port is the arm motor in?
Port 5.
Which port is it in?
6.
It's in port 6, right? So we're going to move the motor on port 6. And I'm going to intentionally forget to put a semicolon here for just a minute because I want you to see something, okay? And we're going to move that. That's going to put the arm down. Sorry, port 6. We're going to set a power level. And since we want the arm to go down, we're going to go to negative 127, negative max power. And I'm going to intentionally forget a semicolon for a minute because I want you to see something. When I go to download this to my robot, I get a little yellow X right here. Okay, that little yellow X is indicating that there is a syntax error. And most of the time when you have a yellow X, it's because you're missing that semicolon. Okay, so I need to go back and put that semicolon in, and then when I download it to my robot, I don't have the yellow X anymore, and I'll be able to see if we're doing the right thing. So let's try that. Let's go to the first view and let's play. Play. Oh, what happened to our arm? Did you notice?
No.
Okay, so let's watch our arm for a minute. What happens when I push play?
It goes up.
It actually went up, didn't it?
Yeah.
Okay, so that means that this motor was not going the direction we wanted it to go. It was reversed. So what should I do to this value instead of calling it negative 127?
Positive.
Positive 127. Did you notice anything else that happened weird with the robot?
No.
Okay, let's download this and see what happens. Oh, my code crashed. Love it when your code crashes. That's good. Pulling up the code again. Let's see. Robot C. Open. SumoBot. Open. Okay. So we're going to go ahead and compile this, and we're going to download it to our robot. We got to go back now and fix this stuff to make sure we go to the virtual world. All right, we're going to log into CS2N. We're using the SquareBot, and we're doing Sumo, and let's start the activity. All right, so we're going to click play. Okay, so that's where we are so far. We moved the arm down and we ran up into this. The only comment that I'll make about putting the arm down is we never stopped the arm from going down. It just went down and it's still pushing down forever and ever and ever and ever and ever. So we probably could have used a timer there. What command could we use for a timer?
Wait 1 msec.
Wait 1 msec. And let's just do that for, I don't know, like 1 second. I don't think we need it very long. We just need to get the arm down to the ground. Okay. So now let's go ahead and download it. And let's see where we are. So we should get our arm down and then our robot drives forward. What did you want to do next with that arm?
Lift it.
Lift it. Okay, so what I'm going to do is I'm going to copy this code right here. So I'm going to highlight over it and copy it because I want a very similar code, right? The only difference now is instead of move arm down, I want to move arm up, which means the value here needs to be negative 127. And my comment is going to shift to say move the arm up for 1 second. Let's compile that and let's see what happens to our robot now. So we go down, forward, and we lift it up. Notice what happened when we lifted it up is it flipped to a different side. So what might we now need to do to push that out of the ring?
Move the arm down.
Okay, let's try. Let's see where we're stuck, by the way. So when we look at this, I wonder if once we flip it, let's try that one more time. We flip it over, flips the cans over. I wonder if we can just push it at this point, now that it's on that different surface that has less friction.
Oh, yeah.
Let's see if we can push it. Let's see if we can just push it out now. That's what we thought we were going to do in the beginning, right? So let's do essentially, we're just going to copy this middle thing, right? Because this middle thing is just to move forward our code. So I did a copy paste of all of that. So now we're going to move forward for another 4 seconds. Okay, so let's compile that. And let's download that and see what happens. All right, arm goes down, robot forward, flip the cans over. Ah, we got it. We got them out of the circle. Let's refresh again and make sure that our code is doing it consistently. Because it didn't actually flip the cans all the way over that time, but it still worked. Ah, either way it works, right? Whether the cans flip or not, once we kind of got them off the surface a little bit, it was able to have enough power to push it. And so that is now that I reached that success, this code works. Okay?
Yeah.
What questions do you have for me about what's going on in this code right now?
I don't have any.
You understand everything as that happened right there?
Yeah.
Perfect. So here's what you need to do next. Once you've built this code, you're already going to get credit for it in CS2N. So I'm going to pull up my CS2N real quick so you can see CS2N. And I'm going to look at my progress as a participant in this because I'm also running through all of these things with you guys. So you had to go through program dissection, reversing motor polarity, renaming motors, timing, and then you went to activity SumoBot. Activity SumoBot, you will now have credit for. You see how I have this little check mark here that says I finished it? That will happen as soon as you finish it in the Robot Virtual Worlds, you will get that little check mark. The other thing you need to do is you need to click on upload code from SumoBot, and you're going to say choose file, and you're going to go find that file wherever you saved it on your desktop. And you're going to submit the file as well. So in addition to getting credit for doing it, I want to look at your code and make sure that you're using all of the correct syntax and make sure that your comments are correct. So I need you to submit a copy of that code as well.
Okay.
Okay? Any questions for me right now?
No.
No? All righty. Go ahead and get started on that, and I will talk to you later, bud.
Thanks. Bye.
You're welcome. Goodbye.